last track meet today, so pretty exciting. This should be possibly our last video of the year. I know seniors are definitely going to have this as their last one. We don't have a whole lot for this section, so I'm just going to probably go over the equations really quick and at least let you guys get a start on your work while I'm gone today. So I'm going to go over these three equations. This first one is called Malice's law, and it talks about light being polarized and the intensity of that light. So if we have two polarizing filters, and they're each going to have an angle that it polarizes light. So this first I is the light intensity after the first filter. So the light intensity after the first filter times cosine squared, and then theta is the angle between these two filters. So the angle between their filters. And then this one is the light intensity after. After the second one. So we have light intensity after the first one times cosine and the angle between the filters, and light intensity after the second one. Now that equation's not too bad. The other two are basically variations of our Doppler effect we had earlier. So this is talking about observed light frequency. So I'll abbreviate that, OBS, light frequency. You can see that that is what we have over here. So the frequency you're going to observe is going to be equal to the actual frequency. And then C is speed of light. And we have a constant for C, so that's always going to be the same, 3.0 times 10 to the 8th meters per second. And then the velocity is the relative velocity. And then the one note I put down for you guys is you see a plus or minus sign, so it is going to be plus if the objects are moving toward each other, and negative if they're moving away from each other. And then our last equation is kind of the thing, but this is the Doppler shift, and this is for wavelengths. So the observed wavelength, so we have observed wavelength minus the actual wavelength is going to be our change in wavelength. And then that is equal to plus or minus, and this is the velocity over the speed of light times the actual wavelength. One of the things that you guys need to remember when you're doing these problems is a lot of the time, because light waves are so small, where they are going to give you nanometers. So like if we look at problem 1, it says 513 nanometers. 1 nanometer is 10 to the negative 9th meters, or 1 times 10 to the negative 9th. So like if they gave me 513 nanometers, that would be 5.13 times 10 to the negative 7th meters, because I would multiply by 1 times 10 to the negative 9th. Other than that, use meters per second for your velocity. Speed of light, use meters for your wavelength. And you only have a couple problems, so this shouldn't be too bad. Let me know if you have questions. I'll be back tomorrow. So thanks, guys.